Hi everyone. So apparently the first recording, the voice wasn't correct, so I'm going to redo this again. I might go a tiny bit faster. I think it's going to be better for you because I'm going to do less repetition and wasting time, but you're still going to get all the material. The first thing I wanted to say is I posted a solution for the midterm. Okay, I didn't post any solution for question 1 to 7 and question 10 and 11 because they're just multiple choice or true and false, and I think you can easily verify these by yourself, and they were also copy paste from the quiz. You might not have gotten those questions in the quiz because it selects a random number from a pool of question, but they were pretty similar from those. The rest, the black is comments that I have to make. The green is answer. And for the mathematical questions, all the mathematical questions, the numbers were randomly generated. So you'll have gotten different numbers than I have here. So what I did is I took an example questions. All these example questions are in purple. These won't be your numbers that you got again, but it's to give you an idea of how you were supposed to solve each of these problems. So hopefully this helps you kind of go through your exam and find the answers that you should have gotten. There's a couple that I do longer answers when I know or I feel like the questions will be harder for you guys to solve, and that they were harder questions, and I kind of do a little bit more to explain what's going on. But anyway, you should use that. You should go over your midterm once it's graded, and you can make sure that the grade I give you is consistent with what I have here. You won't have the midterms until all of them are graded. I know some people are already graded. But I don't know how to withhold the grade until everyone's graded, so you're going to get it as soon as I'm done with your copy. But once everyone's done, I will unlock the exam, and you'll be able to see your points on each question, and you'll be able to see the solution. Last thing is just be careful when you go over your own exam. You'll see the check mark and the X saying it's good or not good based on what the computer did. You want to look if I gave you points. Okay, if the computer gives you bad, it doesn't mean I didn't give you all your points. So just make sure don't use the check marks and the X from the computer. Use the points I gave you as a guideline if you got it right or not. Okay, so that's about the midterm. Okay. Chapter 10 should be a pretty easy chapter. There's a good thing with me redoing it is I thought yesterday I took way too much time to do it. It shouldn't take you 80 minutes to do chapter 10. It's a pretty straightforward chapter except for the last part. Basically where we're going right now is we want to start thinking about capital budgeting decision. We want to start thinking about how do we make decision as a firm on which project we should fund and which project we shouldn't fund. Okay, in order to do that, we need to know the cost of capital for the firm. What is the cost of raising capital for our firm? And so this chapter here specifically, in the next chapter, we'll start to look at that. What is our cost of capital? In this specific chapter here, chapter 10, it's basically just time value of money. Okay, so it's all things you should know already. I think you should know these from previous classes. It's all time value of money about how do we find rates of return for the firm specifically. Okay, so right, and here's a little part where I talk about the fact that financial markets, right, exchange, like the stock exchange, are really useful for firm because it allows them to have real-time information on the required return on the projects that the firm does. Okay, by seeing a lot of the information on the market, the firm can back out, okay, the required rate of return on different instrument for it. The bonds, right? What's the rate of return on debt that it should pay? What's the rate of return on equity that it's expected to generate? And what's the rate of return on preferred share that it's expected to generate? So this whole chapter is about rates of returns and how to find that. And then there's a small portion, probably the hardest part. Okay, hopefully you didn't hear me swearing here. The computer kind of exploded, and I'm getting annoyed at, since the previous recording didn't record correctly. I'm getting kind of annoyed at it. Hopefully you didn't hear too much swearing. Okay. Okay, so we want to find these rate of return. That's what we're interested in because we are interested in knowing how much return we should generate for our debt holders, shareholders, and so on and so forth, and on the project we're doing. All of these little parts will become clearer as we do the further chapter, but basically in that chapter we're just interested in finding the required rate of return on our debt, our equity, and our preferred shares. Okay. First, I have a little parenthesis here about rates of return. Firms that are riskier, okay, usually find that the required rate of return on their securities is also higher. So people want a higher rate of return if there's more risk. This should be obvious from things we talked about since the beginning of the class for you. Whenever we talk about rate of return, a rate of return is made of three principal components. The first one is the real required return that people want. Then there's an inflation premium that is added onto the real required return. And then there's a risk premium. The risk premium is made up of a ton of different risks, not just these three. So it's just a risk premium that kind of adjusts for how risky the security is. So basically your required return, right, on a security is the sum of these three things here. The risk-free rate of return, okay, we are often going to refer to the risk-free rate of return more in investment than in corporate finance, but it's still important to know the risk-free rate of return is the real required return plus the inflation premium. Okay, and usually we use as the risk-free rate of return. Usually we use government bonds, government Canada security, or government American bonds, okay, or treasury bill. This is usually what we use as a proxy for the risk-free rate of return because there's not a lot of risk on government securities. Okay, at least not a lot of risk premium. The inflation is taken into account. The real required rate of return is taken into account. Okay, so this should be pretty straightforward for almost everyone. Basically, we want to find what's the required rate of return on securities for the company. Okay, the company issues bonds, so we need to understand how to price bonds and then how to back out a yield out of bonds. So all of this is pretty straightforward and it's really close to what you did in chapter 9, so I don't think this should be too complicated here. The only thing is I'm introducing a little bit more vocabulary. Okay, so a bond is a certificate, okay, promising to pay back a specified amount of money, redemption value, in the future. Okay, usually bonds will make interest payments, okay, during the life of the bond, and these payments are called coupon payments. There are bonds that exist that have no coupon payments. These bonds are called zeros. Okay, zeros because they do not pay any coupon payment. The coupon payments are zero. So basically, when you buy a bond, you're going to pay P today. You're going to receive coupon payments, oops, over the life of the bond. And then at maturity time N, you're going to receive the maturity value, which is the redemption value, and the last coupon on your bond. Okay, the price would be P, this value here. How do we find it? Pretty straightforward. I find all of these, I take all of these future values, right, all these values that are in the future, and I move them back to today. I find their sum of all of them summed together, and that gives me the price of the bond today. So let's just do a really quick example here. Okay, so bonds usually have semi-annual yield. Okay, or semi-annual payments. The interest payments are semi-annual, so usually the yield is also quoted as semi-annual yield on the bond. So if I ever ignore saying a semi-annual interest rate, just assume is a simple, it's a semi-annual interest rate. Okay, compounded semi-annually. So we have a $1,000 5% bond is purchased 8.5 years before maturity to yield 4.4% compounded semi-annually. If the bond interest is payable semi-annually, what is the purchase price for the bond? So the only issue often here for a lot of students is the idea, right, that there's two interest rates, and that confuses some students. Now it's not really that complicated if you take your time. Okay, the bond yields 4% this means the interest rate, the yield, the interest rate on this bond is 4%. This is what you're going to use as your I over Y in your calculator. Okay, a $1,000 5% bond, the 5% is what we call the coupon rate. Okay, it's the interest, it's how we use, it's what we use to figure out what interest the bond will pay. Okay, so I have all the answers here. Basically for n, we just take the number of years. We know that the bond pays semi-annually. Okay, so there's 8.5 years times 2 is our n, 17. The interest rate I told you was 4. There's 2 payments per year, 2 compounded periods per year. How do we find the payment? This is where we use that 5%. Okay, there's 2 payments per year, so we're just going to take the coupon rate, 5%, multiply it by the face value, 1,000, and we're going to divide it by 2 because there's 2 payments per year. Most bonds in the real world, like 95% of the bonds in the real world, have semi-annual payments. So usually when I make question, I use semi-annual bonds. Again, if I forget to specify it, just assume it's semi-annual. If the payments were not semi-annual, if they were monthly, this would be divided by 12 here. This number would be a 12, not a 2. Does that make sense for everyone? If the payments were quarterly, this would be a 4 here, not a 2. If the payments were yearly, this would be a 1, not a 2. But in this case, our payments are $25 per 6 months. Okay, and the face value is usually the redemption value. So this amount is what we're going to get as a future value, what we get at the end. We just compute the PV, the price today, and we get that the bond should be worth $1,071.46 today. Okay. Now, usually, as I said at the beginning, what we're interested here in this class is to find the rate of return, the required return that investors want on our securities. So what we're interested in is usually not finding the price. Okay, usually the price is given on financial market. Okay, we know N, we know the payments of the bonds, we know how much the face value and the value in the future will be for the bond holder, right? The maturity value will be. So what we're actually interested in as corporate officers is to know, what does this imply about the rate of return? So usually using this information, all of this other information, we'll be interested in solving for I over Y. Okay, because imagine I'm a firm and I issue bonds, right? Or I plan on issuing new bonds. One of the most important piece of information for me in deciding if I want to issue bonds or not is figuring out what's the interest rate I'm going to need to pay on these bonds, right? So what I want to solve is for I over Y, the interest usually. Okay, so there's a simple example here. Try to do it, pause the video and try to do it by yourself. Okay, I'll do the answer now. It's a $500 bond, so the $500 is going to be our future value. It's our maturity value. Okay, it pays interest at 9.5% semi-annual. Okay, I told you I wouldn't use the J2 way of writing interest rates. So paying interest at semi-annually at 9.5%. Okay, redeemable at par. Redeemable at par always just means that the face value, this amount, is the maturity value, is the redemption value. Don't worry too much about this in my class. I won't be playing with these. I think it's a lot of vocabulary that you need to get used to. It's fine. Just ignore it for now. All bonds will be basically redeemable at par. So if you ever read that, it's nothing to confuse you here. Just ignore it. Okay. On August 15, 2012, and it is priced at 547.50 on August 15, 2000. Find the yield to maturity, the semi-annual yield rate to maturity. Okay. So we want a semi-annual yield rate. C over Y is 2. The payments are 2 per year. Okay, the payments are 9.5% times 500 divided by 2. That should be 23.75. There's 12 years of payments. Okay, times 2 payments per year. There's 24 payments. The PV, the price people are willing to pay for this bond today, is 547.50, and they will receive $500. At the end, we can solve for the rate of return. Okay, the important thing to understand here is that 8.24% compounded semi-annually, right? This is actually the rate of return that investors require on our debt. So if we raise funds, right, if we decide to issue debt in order to start a project, that project needs to generate at least 8.24% in rate of return. If it doesn't, investors will be charging us more than what the project will generate as a rate of return, and the firm will be losing money and will be losing value. Okay, so that's a lot of what we want to do in the next chapters, but right now we just want to look at these, right, and see what's the required return for the debt holders in our company. Okay, this is relatively important, but there's not a lot of maths here to do. It's mostly just theoretical. So this is a good place for discussion questions for your second midterm. Okay. I want to talk about the sensitivity of bond price with regards to different things. Okay. I'll leave the slide here, but I won't use the slide because I think it's a bit more obvious to see other places. The first one I want to talk about is the convexity of bond prices. Okay, bond prices are said to be convex. The reason it's convex might be kind of weird now, but once you see it graphically, hopefully you will understand why this convexity, that the word convexity makes sense. The basic idea is that suppose this is a bond that was issued, right? The coupon rate and the yield to maturity was 10%. Under these circumstances, you can try to verify with a whole bunch of bonds you create, but if the yield to maturity and the coupon rate are the same, the bond should always trade at par. Its value should always be equal to the face value, the redemption value. So this is a $1,000 bond. If the yield to maturity is the same as the coupon rate, then the price should be 1,000. Okay. Suppose that the interest rate decrease. We know that the price of the bond should go up, right? Convexity means that as the bond yield decrease, the price of the bond should increase at a faster and faster pace. Okay. So here, if you look, when we go from 9%, whoa, this is ugly. When we go from 10% to 9%, there's an increase in $91, roughly 91.29, in the value of the bond. When the interest rate decreased from 9 to 8, by how much does the bond go up? The bond price goes up by roughly 105, right? So as the interest rate decrease more and more, the acceleration in the increase in the bond price keeps getting bigger and bigger and bigger. Okay, and I don't want to do all of these, but try to do more if you want. You'll see that there's always bigger increase in bond price as I move up. Okay, and convexity also says that on the other side, as the interest rate goes up, we know that the price of the bond should go down. Okay, but convexity says that the price of the bond will go down at a decreasing rate. Every time the yield to maturity decrease, the decrease in the value of the bond will become smaller and smaller. So for example, when we go from 10 to 11, we notice a roughly minus $80 in the value of the bond. When the bond goes from the yield goes from 11 to 12, we see about a $70 decrease in the price of the bond. Notice we could just go from 12 to 11, that would be plus 70 and that would be plus 80, right? But it's still the same idea as convexity, right? As we go up here, the increase in the prices get bigger and bigger and bigger, and as we go down that way, the decreases in the price become smaller and smaller. Okay, this is my first point here. It's convexity of bond prices. Okay, why is it called convexity? Because if we were to draw this on a graph, right, suppose we put the yield here, so that's the interest rate on our bond here, and we put the bond price above on this axis here. Okay, when the yield is 10%, we have a given price. It was 1,000. Okay, what I was saying is when we're moving this way, when the yield decrease, the price of the bond increase at an increasing rate. So that means that at first, right, it's going down, and the yield is going down and the price is going up, but it's not going up that fast, and it keeps accelerating. Okay, and when we're going the other way, the decrease in the price of the bond, right, gets smaller and smaller over time. So basically what we have, this is a curve. Hopefully you see it, like I'm trying to draw a curve basically in that shape, right? That's what I'm trying to draw here, but it's a little bit hard with this to draw. But this is this convexity. This is a convex curve, right? And this is why we call it convexity of bond prices. Okay, because they're convex. And as the yield increase, I lose money, but I lose less and less money every time the yield increase. As the yield decrease, I gain money and I get more and more and more money as the yield increase. Now, I don't want to talk too much about this, but the convexity of bonds is different. Okay, some bonds will be really convex. Could be here. I should probably do them in a different color, right? So much more convex. Some bonds could be less convex. Does that make sense? I'm not really good at drawing it here, but basically the tighter, right, this is here, the more convex the bond is, and the straighter this is, the least convex the bond is. Okay, and convexity is a valuable aspect of bonds. Okay, it's really useful for the owner of the bonds, right? So usually bonds that are more convex have a higher price. Okay, we won't talk too much about what generates convexity of bonds, but it's important you know about it. Okay, the second part is how the time to maturity is related to the impact on the price of the bond. Bonds that have higher maturity, that are like have a longer time to maturity, okay, will tend to react more to change in the yield than bonds that have a lower maturity. In fact, when a bond is due the next day, right, just the day before, the day after, well, then the bond price should basically be the face value, right? It's actually kind of wrong here. It should be the face value plus the interest on it, because you're going to receive an interest payment, right? But that should be the price of the bond. Okay, and you can see that bonds that have maturity of 1 or 5 years, okay, their price doesn't vary much. I should say this before I go further. Remember here, this is a bond with a 10% coupon. Okay, if the yield was 10%, the price of this bond, no matter at maturity, would be 1,000 everywhere. Okay, as I said earlier, whenever the yield is equal to the coupon rate, the bond will be set to trade at par, and the face value and the price will be the same. Okay, when the yield decrease and goes below the coupon rate, which is 10% in this case, then the price of the bond will go up. When the yield increase and goes above the coupon rate, then the price of the bond will decrease. Okay, the point this is trying to show is that the decrease in the price is much bigger for longer term bonds than it is for shorter term bond. Okay, similarly, the increase in the price for longer term bond is much bigger than the increase in the price for shorter term bonds. Does that make sense for everyone? That's all this is trying to say, and this is my second point. This is that point here. Okay. Finally, over time, bonds. This is a graph here representing this information. Finally, over time, bond price are dragged back to par, okay, or to their maturity value. So the idea here is pretty straightforward. Suppose a bond is issued. There's a 10 coupon rate and the yield is 10%. Okay, it's issued here. It has 30 years left to maturity. Okay, 2 weeks after the bond is issued, there's a shock. The interest rate goes up by 2%. Okay, now the price of the bond went down and it's now 8.38. You can see it here, right? in this side. If the interest rate were to stay 12% for the whole life of this bond, the bond value would slowly increase every year until at maturity it would be back to being worth 1,000. Okay. Same thing if after the bond was issued, the interest rate would have went down, the bond price would have jumped to 1,000 something, and if the interest rate didn't change for those 30 years, then the bond price would slowly go back down to 1,000. Okay. Obviously, in the real world, the interest rate doesn't stay 12% for the whole 30 year of the bond, or 8%. So what ends up happening in the real world is that we're going to be on this trajectory here. I'll erase it. Okay, we're going to be on this trajectory here, and then the interest rate will go to 11. So the bond price will jump somewhere here, and then it's going to keep going like this, and then the interest rate will jump back to 12, and we're going to go back here. It's going to jump to 13, we're going to go back here. So in the real world, it's not really this green line because the interest rate actually changed all the time. But if the interest rate was not to change, the price of the bond will be pulled back to par. Okay. The next thing I want to talk about is the preferred shares. There's two types of preferred shares in the real world. In your class, you probably always talk about perpetuals. Okay, they are preferred shares that pay a fixed dividend every year for perpetuity. That's why they're called perpetuals. Okay. While these are still a big proportion of the preferred shares issued today on the market, I shouldn't say issued, that have been issued in the past. Most issues nowadays of preferred shares are actually rate reset preferred shares. Okay, so there's still probably more perpetual on the market today than there are rate resets, but almost all of the new issues are rate resets. Okay, in this class, we will only talk about perpetual because they're way easier to price and they're way easier to use. Okay, the reason I'm talking about both is that perpetual preferred shares behave a lot like bonds. So when you listen to what I'm talking about now, you're going to be thinking like these are pretty close to bonds, and often we kind of call preferred shares a simile debt instrument, right? It's something that's really close to a debt instrument. It's called equity, but in truth it behaves a lot like a debt instrument. And that's true for the perpetual preferred shares. The rate reset shares behave differently. So I won't test you mathematically on rate reset preferred shares, but I want you to know what they are and to be able to explain the basic logic of rate resets preferred shared. Okay, and the reason I'm explaining it is pretty straightforward. In the real world, you might see rate resets preferred share. You see preferred shared, and then you see them behave completely different than what I told you they should behave like. That's probably because they're rate reset. Okay, so what are rate reset? Perpetuals are pretty straightforward. As I say, they pay a fixed amount every quarter forever. Okay, rate resets are a little bit different. They're going to have their interest rate be tied to a benchmark interest rate. Okay, so for example, the Government of Canada 5-year bond. Okay, so the rate resets, when you read them, when you read the prospectus, which I've made my student read in the past, and everyone's like, this is boring, I don't want to read that. I'm sorry, this is finance, right? Like the prospectus is a big part of what these shares are. But if you read the prospectus, they're going to say something like this: Government of Canada bond. You should probably write this, right? Because I'm writing it, but it's not writing it really well, and it won't stay. Government of Canada bond, or 5 years. 5-year bond plus 2%. So basically a rate reset will basically have something like that, a clause in there that says the interest rate that this preferred shares will pay is going to be the Government of Canada 5-year bond rate, right? The interest rate on that 5-year bond plus 2% or plus 3% or plus 4% or plus 1%. This plus here, where does it come from? Stop the video now. One student told me that he would like it if there's more discussion question. So this is me trying to do a discussion question here. Pause this and using what I talked about earlier, explain to me why there would be different numbers here. These numbers will depend on what? Pause your video, think about that. Okay, these numbers, right, these pluses here, that's the risk premium, right? The Government of Canada 5-year bond is considered the risk-free rate. So if we go back to my previous slides, up here, right, the government of Canada doesn't have a risk premium because it's riskless. Okay, but these other companies that are trying to issue preferred share, they're more risky than the Government of Canada. So people will want to be compensated for that risk premium, and so this you're going to give investors a certain benefit, right, a certain rate of return above the Government of Canada 5-year rate to compensate them for that risk. And that's where it comes from. It's all about the risk premium. Okay. Okay, so rate resets will behave like this. So basically a rate reset like this would take the Government of Canada 5-year bond rate and add 2 or 3 or 4 or 1%. And the interest rate or the dividend basically that you get on these shares will be reset every 5 years based on the formula that we just talked about here. Whoa. Based on this formula, right? What we just wrote here. Okay. So this is why they call rate reset, right? Because the rate, the dividend yield you get on them resets every 5 years or every 3 months, or it depends on, all of them are different. So it depends when they reset on the prospectus. Okay. The important thing that you should know is that these rate reset, what do you think happens to their value when the interest rate goes up? Now, again, you can pause the video if you want more discussion question. Pause the video right now, well, after I said the question, and think about this. How do perpetual behave when the interest rate goes up? How do rate reset shares behave when the interest rate goes up? Try to think about that. Stop the video, think about it. Okay, the idea is pretty straightforward. Perpetuals are basically bonds. They're bonds that last forever, right? A bond just gives you an interest payments, and then at some point they repay the loan back. Well, a perpetual preferred share is the same idea. They just give you a payment, a dividend every year, but they never give you the principal back because it's considered a perpetuity. It's going to last forever as long as the company's there. So they behave exactly like a bond. If the interest rate goes up, the price goes down. If the interest rate goes down, the price goes up. Rate resets, on the other end, behave the other way. Because if the interest rate goes up, you're going to get more dividend out of these shares. So now they're more valuable. Okay, and this is the reason I wanted to explain a little bit rate reset, because if you look at rate reset on the stock market, you go to buy on the Toronto Stock Exchange, you go to buy rate reset preferred share, you're going to notice that they behave the opposite way of what you've learned in most of your card class about perpetual preferred shares. I've never seen another Prophet Camosun teaching, or even UVic teaching rate resets, but this is really what is issued now. So if you buy rate reset, you might be surprised, right? You're buying them thinking, oh, the interest rate is going to go down. I'm going to make a lot of money. I think the interest rate is going to go down. I'm going to buy preferred shares. And then when the interest rate goes down, the price of your preferred shares go down, and you're really unhappy. Okay, so be careful. Verify which type you're getting if you ever want to buy preferred shares. Okay, so I explained all of that. Now, this being said, the math is a lot easier for perpetual, so I will, just like most other profs, just use perpetuals to do the math here. It's a lot easier. I think you should be able to do these questions. So try to read these and try to do these questions. I'll give you the answer in 30 seconds, or whenever you stop the pause. Okay, the answer to this question, the first two are basically the same. A company is expected to pay a dividend of 90 cents every 3 months for a share of its preferred stock. What would a share of the stock be selling for if money is worth 7% compounded quarterly? The interest rate is quarterly. The payments is quarterly. The interest rate is 7%. It's a perpetuity. So I don't know that we did a lot of perpetuity in this class up to now, but basically my trick is always to use 500 years. Not N is 500. You use 500 years. So 500 years times 4 payments per year, you use 2,000 as your N. Okay. The payment is 90 cent positive. every quarter. I compute the PV. I get the PV is 51.43. That's the price. That's how much the share should be selling for. Okay. Here is the same question. The only difference is I changed the interest rate on the preferred share. So basically the yield change, and this is just to show to you what I just talked about with perpetual. This is a perpetual, right? This 90 cents forever, so it's a perpetual share. We know that the price of the share should go down if the interest rate goes up. This is just to show that. N didn't change. P over Y, C over Y didn't change. The payments didn't change. Everything is still the same shares, but the interest rate changed. Okay, and we can find that the price of these shares should be $36. Finally, this is more what you're going to do in this class. I told you what we are interested in this class is to figure out what is the rate of return that is implied by financial market on security of our company. So we already found what's the required rate of return on our debt. That's finding the yield on our bonds. We can find the required return on our preferred shares. What do? Well, we know the price of our preferred shares today, right? We know how much dividends they pay, and we can use that information to figure out what is the required rate of return that investors right now want to get on our preferred shares. Okay, so this is what we're doing here. There's a company that pays 1.5 dividends. That's my payment. Okay. Oh, this is bad here. I am not doing any annuity dues, so that shouldn't be there. I told you we wouldn't do annuity dues at the beginning of this semester. If the shares are trading at $70, what nominal rate of return compounded semi-annually will they provide to the purchaser? Well, again, we have 500 years with 2 payments per year. Okay, the payments and the compounding periods are semi-annually. The price today is 70 negative. The payment you're going to get is 1.5. We compute the interest rate, 4.29% compounded semi-annually. This is the first video. We're done. The next part will all be about common share valuations model. This is the harder part of this course.